So the concepts for tonight in this session is the first one we're going to talk about is order of operations. And hopefully you can see that okay, order of operations and averages. Those are kind of the two main concepts. So what I'm going to do is I'm just going to let you take a moment. I'll pause my recording and okay, hopefully you've had time to copy down those, what you see on the screen here. And in math, there is something called order of operations. And what it means is the order that you operate in, okay? Do this first, do this next, and then this next. That's what we talk about. When we talk about order, that's what we mean. What goes first, what goes second, what goes third. So for instance, if you look at my first example that I have, that you now hopefully have in your notes here, I've got 9 plus 6 divided by 3, okay? Well, watch what happens. In the order of operations, it says that we should do whatever's in parentheses. See how it spells PEMDAS, by the way, down here, P-E-M-D-A-S. People start kind of memorizing that word PEMDAS. It's kind of a nonsense word, but it has all the letters of the order of operations. P for parentheses. Do what's in parentheses first. Okay, and if there's nothing in parentheses, then the next thing is you do what's in an exponent. And as a review, an exponent, if I had like 3 to the second, okay, its exponent is that little number on the top there. That's the exponent, okay. And then the next thing you do, the next order is to multiply and divide, okay, from left to right. So I'll put L to R over here, and you could add this to your notes, okay. You do these from L to R, left to right, all the way down, okay. You go from left to right at that point. But the order is do the parentheses first, then do the exponents, then do the multiplication, then division, then addition and subtraction, going left to right, okay. So in my example here, I look at 9 plus 6 divided by 3. Okay, is there anything in parentheses? No. Is there an exponent? No. Multiplication, it says in division, I do next. Okay, I do these two are kind of what comes next is multiply and divide here. Okay, in the example I have here. Okay, so these first two numbers are addition. So I don't do those first. I do what's here over here first. Okay, so so what I'm going to do is I'm going to take 6 divided by 3, and I'm going to get a 2. Hi, Bila. We're recording tonight, so I'll have you just leave your camera off and your microphone off, okay? So in the order of operations, I'm going to do the division first. 6 divided by 3 is 2, and then plus, it says plus 9. So 9 plus 2 is 11. All right, I want you to notice something. Okay, I got an answer of 11. 6 divided by 3 is 2, plus 9 is 11. What if I didn't follow that order? What if I went 9 plus 6 is 15 divided by 3? I would have gotten the answer 5. You see why that's important? If I just went straight across and didn't follow that division comes first, 9 plus 6 is 15 divided by 3 is 5. Look at the difference in the answers here, okay? So that's why, it matters what order you do things in when you do multiple steps in an operation of multiple steps. That's why they have an order. Okay, so if you ever wondered why, bingo, there's the reason right there. You get totally different answers depending on which order you do things in. Okay. All right, let's do a couple of examples. So I'll give you about 10 seconds to copy down these 3 examples, and then we'll work through them. Okay. Looking at example number 2 here. The rule is do what's in parentheses, the P, that's for the parentheses in PEMDAS, which I rewrote. You might as well Rewrite this in the margin here to the right here, just reminding yourself, yeah, PEMDAS, parentheses, exponents, multiply, divide, add, and subtract. Do what's in parentheses first. See how these little things here, these little bracket-like things are called parentheses in English, okay? 8 minus 3, 8, 7, 6 is 5, okay? So now this becomes 5 times 4. When, in case you didn't know this, when you see something out just right next to each other by parentheses like this, that means times, okay? And so 5 times 4 is 20, okay? Let's look at example 2 or 3 here. I have nothing's in parentheses, nothing's in exponent, so I go to the next one, multiply, and then divide left to right. So 7 times 3 is 21, minus 4, okay, is 20, 19, 18, 17, 17. Okay, all right. All right, so we're going left to right. We're following the PEMDAS, following the order of operations here, okay? Let's look at example 4. It's a little bit more complex, okay? Rule number 1, P, parentheses. Do what's in parentheses first. Do we have something in parentheses? We do. So I would rewrite this as this, 3 times, okay, if I want to write it like this in parentheses. What's 4 plus 2? I do the math that's in the parentheses first, okay? 4 plus 2 is 6, okay? So I kind of wrote it like that, okay? Minus, and this is 12, but 12 divided by 3 here. I'll just rewrite it here. I'm just showing one step at a time here, okay? All right, so I did the stuff that's in parentheses first. Then it says we do exponents, there's none. Then we go to multiply and divide, okay? Well, I can multiply, okay? 3 times 6, and this gives me 18. Minus, okay? Now, you'll notice I didn't just say minus 12. Why did I do that? Because look what's next in my order of operations here. It's multiply, then divide. I've got some division right here I need to do first before I go down to subtracting, okay? 12 divided by 3 is 4, okay? So now, I took these two things here. I'll just put it in parentheses just to focus. I make it clear. Those two things got me 4. Now it's 18 minus 4, which equals 14, okay? So I walk through the order of operations going down the line, P, E, M, D, A, S. And when I get to the MDAS, I do them from left to right. Okay, multiply, divide, add, and subtract. All right, let's take something a couple that are a little bit more complex. Okay, and so go ahead and copy number 5 down, which is 6 times 6 divided by 3 times 2. Okay, and we'll walk you through that one at a time. Okay, order of operations. Again, I'm going to write P, E, M, D, A, S. And you might get in the habit of doing this on your notes for a while until you've got it memorized. Just keep reinforcing. If you flip the page in your notebook and just write PEMDAS again, just so you can glance at it real fast, okay? Order of operations, parentheses first. These things right here are in parentheses. I have to do them first before I can do whatever's next, okay? So 6 times 6 is 36. I'm going to put it divided by, and then I'm going to do what's in parentheses first here. 3 times 2 is 6, okay? Well, that's going to give me 6 real fast. That's pretty nice and easy, okay? All right. Let me jump to number 7 here, because number 6 is the same idea, okay? Take a moment and copy down problem number 7, which is 8 times 3 divided by 4 minus 3 times 4 minus 4, okay? Okay, again, following my order of operations, PEMDAS, P, parentheses first. All right, within this parentheses, I've got multiplying and dividing going on. So I have multiple things going on, okay? The M looks like comes slightly before the D. Okay. So that means I'm okay just multiplying first. Okay. 8 times 3 is 24. You got that? This becomes 24 here. Okay. If I just kind of wrote this here, this becomes this. Okay. Divided by 4. Okay. I'm going from left to right here. 24 divided by 4. Why does that seem funny to me? Because it's not a clean one. That's why. Yeah, this becomes a fraction or a decimal here. That's why it should have been something different. It should have been 3 times 7 or something. Anyway, this should have been a 3 right here. Sorry, guys, just to make it cleaner. But I'll show you what we would do. We would do 24 divided by 4. Well, 4 times 5 is 20. 4 times 6 is 24. What? It goes into it 6 times. It's clean. Okay. This becomes 6. Okay. 6 times 4 is 24. Right? Yep, that's right. Now I've got minus. Okay. I'm taking this minus here. I'm bringing it down here. Minus. I've got, you see how I've got 3 times, I've got 4 minus 4. I have to do what's in parentheses first. Okay, so I did all the parentheses stuff here first. I'm going to now do its parentheses first and then multiply. I'm really emphasizing that to be sure to do what's in the parentheses, all that first. So 4 minus 4 is 0, right? And so then I've got minus, but I'm supposed to multiply before I start subtracting. So I would do 3 times 0 is 0. So really 6 minus 0, right? So this is minus 3 times 0. This is all this right here became 0, okay? Are you following me? And so I take the 3, multiply is next, right? I did parentheses first, then multiply is next. Minus 3 times 0 is 0. So 6 minus 0 is just going to be 6. Okay, it simplified it real quickly here. Now, I'm not going to go do the whole problem for the sake of time tonight because I have a bunch of other concepts. But in number 8 here, I would do, you see I've got parentheses within parentheses here. Can you guess what you'd do first? You would do this first because it's the parentheses within the parentheses first, okay? Likewise, over on the right side of the problem, divided by, I would do this parentheses within the parentheses first to get an answer, then multiply it by 5, etc. Okay, so that's order of operations, and you'll get a chance to practice that and be quizzed on it. New concept I want you to write in your notes is this concept of exponents. I think we've talked a little bit about this already in this course, but exponents, they are, if you can write my example here, a nice big 4 on your notes here. It's that little number up above to the right is called the exponent, okay? And just so you know, if you ever wonder, well, if that's the exponent, I'll circle it here. If this is the exponent, what's the base number called? It's the base. Actually, some teachers will call it the base number, okay? So what does an exponent mean? It means you multiply the base times itself, excuse me, however many times you have of the exponent. Let me say that better. So in this example, there's the exponent to 2. So this really equals 4 times 4, okay? And it equals 16. So I multiplied it twice because there's a 2 there, okay? So the base number 2 times basically is what that means, okay? In my second example down here, 2 squared, if you want to write this in your notes here, that's the 2 and how many times? Twice. So it's 2 times 2, which is 4. 2 squared equals 4, okay? Likewise, in, I'll take problem number, the last one down here, 2 to the 4th is how you would say it out loud. This little 4 is the exponent. It's 2 4 times, okay? So it's 2 times 2 times 2 times 2, which equals 4 times 2 is 8 times 2 is 16, okay? So you probably heard that before. That's what an exponent's that little number on top, and it just means multiply the base times each other, times itself that many times. Okay. All right. All right. Having said that, that brings us back to order of operations. So what I want you to do is I want you in your notes just to take, I don't know, 20 seconds and just copy down all three of these. There's actually four of these examples here. Okay. It'll take about 20 seconds and copy down all four of these examples. Okay, we'll jump in here, guys. So this is an example of where we have order of operations, and then we actually have an example or two where we have negative numbers here. You'll notice -3 here, and that's what integers. Remember, we introduced this concept last week that integers have to do with all the positive and the negative numbers, okay? But looking back at number one here, my PEMDAS was parentheses first. There are none. Go on to exponents. There is an exponent here, okay? Well, 9 squared is 9 times 9, which is 81, okay? All right, so this is 5 plus 81 times, this is the little times symbol here that as best as some computers can do it. This is times 2, okay? So times 2 here. I just brought it down. Okay. Now 5 plus 81 times 2. This 9 squared became this. What would I do next? It goes down to multiplication next. So I would take 81 times 2, and if I wrote it out like this, just to do it the long way, 162, okay? So this becomes 162 plus 5, okay? So if I added 5 plus 162, I get a 167 as my final answer, okay? All right, so that's just illustrating that you will see some exponents in your homework and on a quiz. Likewise, in number 2 here, I won't do the whole problem. I just want you thinking it through. Parentheses first, there's no actual operation to be done here, so there's nothing to do there. Exponents next. This is an exponent. 3 squared is 9. So now I have 9 times, and this is -5 here. And then I've got -36 here, okay? And then what I would do is I'm going to do my multiplication next, okay? Which in this case, I could do -5 times, -5 times 9 is going to be -45, okay? Yeah, this is like -5 here. Now, if you thought to yourself, what if I just ignored that minus and just did 5 times 9? I get 45, right? But it's -45. It'd still be -45, okay? So I have a -36 -45. And remember, I don't know if you recall this, but when you're adding integers that have the same sign, okay, you just add up the numbers, or subtract, you just add them up, and you would get 36 and 45 here together. Okay, I'm just gonna 45 here too. Okay, 11, this is a 45, right? And 5, 6, 7, 81. Okay, and I keep the sign. They're both negative numbers, so it'd be a -81, okay? Because I was adding these two together. Okay, we went through that kind of fast, but I think you got at the idea. Do the exponents after you do what's in parentheses here, okay? All right, I do want to show you number 3 over here. I'll give you a couple seconds to copy. It's 12. And remember, what's in parentheses right next to another number, it just means times. It's the same thing as saying 12 times 2. And I want you to copy down, it's a minus, and then you see how it's a -3 here, okay? You may recall from last week that we said there's a rule when you have a double minus like that, it becomes plus when you have double minus like this, okay? And it's kind of the same as when you multiply two negative numbers, it becomes a positive. Well, in that case, what I would have here is 24, because these two become 24, okay? Minus a -3, which means +3. Two minuses makes this number a plus. So I get 27 here, okay? I want to just show you that when you get them together, two minuses, it becomes plus. All right. This number 4 here it looks a little bit complex because, okay, what's the rule? PEMDAS, parentheses first, right? I'll give you a moment to copy down number 4 here. I don't want to rush you. Okay, so I have 8 divided by 2 squared. What's PEMDAS tell me? Parentheses first, okay? So 8 divided by 2 is 4, okay? So now what I really have is this becomes 4 squared, okay? This whole thing up at the top becomes 4 squared because I did the math in parentheses first. And that equals, if I want to just do the math, 4 squared is 4 times 4, which is 16, over, let's look at my denominator down here. Let's do what's in parentheses first. 5 minus 3 is 2. 2 squared is 2 times, so this becomes 2 squared if I wrote out the steps here, which is 4, okay? And then 4 goes into 16 4 times. There's my answer, okay? So all of this gives me the answer 4 by following PEMDAS, okay? The order of operations, but in some cases working with exponents or integers. Okay, I'm hoping that's making some sense to you. All right, you'll run into a problem like this. I wanted to show you kind of a complex one because you'll see stuff like this in homework and sometimes on quizzes. So I'll give you about 10 seconds to copy that. It's 3 squared plus 6 minus a -3 over 9 plus -3, okay? Okay. In my order of operations, P is first, parentheses. Is there any math that actually needs to be done inside the parentheses, just within the parentheses here? There's actually no math needing, there's no adding, subtracting, multiplying, or dividing. There's just a number sitting there, right? So I go on to E, exponents. So what I have is, here's my exponent, 3 to the second is 3 times 3, which is 9, plus, okay, now, okay, I'm going to go from exponents to multiplying and dividing, okay? Is there any multiplication to be done on top here? Well, this is actually 6 plus 3, right? See, the double negative becomes a positive. So if I'm just going to write this out here, this becomes, if I just kind of wrote it above here, 6 plus 3, okay? Right? So 6 plus 3 is 9. Okay, I'm going to go down here to my denominator. Okay, and this is 9 plus a -3, which is just going to be 9 minus 3. Okay, because remember the rule when you're adding opposite integers, you subtract. So I have a +9 and a -3. You subtract and then you keep the sign of the greater number, the greater digit. Okay, so 9 minus 3 is 6. All right. From there, do you know what you would do next? I've got 9 plus 9 over 6, okay? A couple of things you could do. This is a what we call improper fraction. So if I changed it to mixed, I divide the 6, it goes into 9, 1, and there's 3 left over 9, okay, plus 9. Okay, I just brought down this 9 here. If I draw an arrow here, that's one funny looking 9 here. Okay, there we go. 9 plus 1 1/3, which would equal just 10 and 3/9. Okay, I added 9 plus 1 to get 10 and 3/9. And then that last question, I always tell my math students, the last thing you always should do is when you look at your final answer is just think real quickly, can this reduce? And actually it can. This becomes 10 and 1/3 because 3 goes into both of these once and 3 times. Okay, so that's how you would break down a kind of a more complicated one. Going to jump forward here. You've got that hopefully in your notes. A little bit more about exponents. So you might just say more in your notes, more exponents, okay? And these are a couple of more rules that we haven't covered yet that relate to exponents. But I wanted you to see what they look like. And they're actually in some ways similar, but wanted you to see this. So in your notes, if you could write 2 to the first or 7 to the first, okay, it means just 2 times, just one time. That basically is what it means, right? So if you saw something that looked like it was trying to throw you off, what's 7 to the first? It's just 7. It's just 7 one time. 1/3 to the first would just be 1/3, okay? So if you ever run into that kind of a situation in a math problem where they actually throw an exponent up there, normally they don't, by the way, just so you know, you normally wouldn't have a number to the first. But if you saw that, just think that's just the number. There's no actual exponent here, okay? However, what do you do down here? You want to write this in your notes. What if you have 3 to the 0th power, okay? All right. Or if you had 15 to the 0th power, or 3/7 to the 0th power. In your notes, please write that in every single case, any number to the 0th exponent is always going to be 1, okay? All these numbers, they all just equal 1. I know that sounds odd. Why wouldn't it be 3? Well, 3 to the 1 would be 3. So to the 0th power, it's just something that's 1. Okay, so you have that concept. Let's write down in our notes some negative base numbers. Okay, how do we deal with these negative? We're calling them the base because we already talked about what an exponent is, like 4 squared. Okay, the 4 is the base. Okay, that's the base number. How do you deal with negative numbers that have exponents? Okay, so go ahead and write -2 squared. And what that is that base times itself twice. So -2 times -2, you see that's 2 times, okay? Well, a negative times a negative is a what? We learned this last week. A negative times a negative is always going to be a positive. So -2 squared is -2 times -2, which is just +4, okay? Go ahead and copy down -2 to the third, and I'll walk you through that. So -2 to the third just means the base times itself 3 times, like we said. So I've got -2 times -2 times -2. Now let's think it through out loud. A -2 times a -2 would give me a +4 because a negative times negative times a negative is a positive, okay? So I'm just going to draw these lines up here that this would give me that times a -2 again. You notice I have a positive times a negative, and that was the one rule that you always get a negative answer. 4 times 2 is 8, and it's going to be a -8. Don't forget this negative number right here. Okay. So again, I went 2 negatives times each other. I got a +4. I took that +4 and I multiplied it by a -2. So I got a -8. Okay. And let's see here on this next one here, I've got -1/3 to the third. Okay. If you want to write that in your notes, -1/3 to the third. And therefore, that's negative 1/3 times negative 1/3 times negative 1/3. It's 3 times, okay? And that's a negative times a negative, okay? The first two negatives here, if I take these first two on the screen here, if I take these first two here, is 1/9. That's a negative times a negative is a positive. I'll write it down here, 1/9, okay? These become this, a positive. Why? Because you have two negatives times, oh, if I write it out by hand here, a negative 1/3. Okay. And that's that third negative 1/3 here. If I just draw a little arrow here. Okay. 1 times 1 is 1. 9 times 3 is 27. Okay. And then the big question I would ask you at this point is that answer going to be a positive 1/27 or negative? It's a positive number times a negative number. So it would be a negative 1/27. Okay. All right. I hope that kind of reviews some of the ideas of what do you do if you have a to the first power. Okay. All right. Here's another concept, getting ready for algebra here. Negative exponents. Please write this concept in your notes that we're now talking about. What do you do if you have negative? The exponent's negative, not the base. The exponent, the one on top, is negative. What do you do there? Okay. And in your notes, you can write my example here. If I have example number 1 here, I've got 4 to the negative 1th. Okay. All right. Remember when I said 4 to the 1th would just be 4, right? When you have a negative number like that, it becomes 1/4. That's what it becomes. You basically, in a sense, you basically make it like it's the reciprocal of it, in a sense. Okay. Here's what I mean by saying it's the reciprocal. 4 to the first would just be 4, right? It is actually, technically, that's 4/1. What's the reciprocal? The reverse of that is 1/4. Okay. That's the reverse. So if I had 4 to the negative 2, okay, I put it over 1. I put it over 1/4 squared here like this. So you can just copy this in your notes and kind of study it and review it. But a negative exponent basically means you put it over 1. 1's on top. And then you do your exponents just like you normally would at the bottom. So 4 to the negative 2 is 1/4 squared, okay, because that would be 4 squared. So that's 1/16. Writing down another one, 4 to the negative 3rd, okay, means I put 1 on top and then I do my exponents on the bottom. 4th 3 times is 1/64. Okay, because 36 times 4 is 64. All right. So that's what you do with you have negative. So the key with negative numbers is put 1 on the top of it. Okay. Whatever that number is, put it up under 1 and then do the exponent work. Okay. Jumping on to adding and subtracting exponents. We're covering a lot of different concepts. I'm going to confess to you that we are covering a lot of things tonight. So go ahead and copy what you see on the screen and then we'll continue. Okay, let's make sure we review terms here so we're really clear when we talk about adding and subtracting exponents. You know, this word exponent means the number on top. So if I had 4 squared, it's that little number on top. Okay, we know we're talking about that. We know the number on the bottom is called the base number. We call that the base number. Okay, it's the foundation of the whole thing. Okay. All right, so when I have the expression like and unlike bases, in this example number 1, you could probably guess that our base is not like. If I had 2 squared plus 2 to the 3rd, then our base would be the same, 2's. But in this case, we don't. We have 2 different numbers, so our bases are unlike or different, okay? And so what I would do is I would just treat them separately and go 2 squared is 2 times 2, which gives me 4, plus do the math for the 3 squared. 3 times 3 is 9, times 3 is 27. 27 plus 4 is 31, okay? So when you have unlike bases, okay, then just do the math first and then add those numbers together. When we're adding and subtracting, or if I was subtracting, it would do the same thing, but this plus sign would be a minus, okay? And it would be a minus here. okay? Likewise, in number 2 over here, I've got 3 squared plus 4 squared. I look right away and I see I've got different bases. So I have to do the base math first. 3 squared is 9 plus 4 squared is 16. So that's 25. Okay. And likewise, in this next one, I've got 4 squared minus 5 squared. The base is different. So I'm going to do 16 minus 5 squared is 25. That's going to give me a negative number. Okay. So that's how I handle it when the bases are unlike. All of these examples on this page is we have unlike bases in every single case. In every single case, we have unlike bases here. This base number here is unlike that base number. Okay, hope that kind of makes sense. Let's jump on to what about multiplying? What if I'm multiplying and dividing exponents? Okay, so yes, we're covering a lot of ground tonight, admittedly. This is why I'm making this recording. Multiplying, so in your notes, just write down multiplying and dividing exponents. Okay. Okay. So I think I gave you some time to copy these down. Okay. All right. So let me show you here a little example here. When I wanted to show you this kind of rule here that when I'm multiplying the bases with like numbers, you add the exponents. Okay. So I wanted to show you this idea that if I have my bases are the same, okay, and you can write this in your notes here first, I guess. My base is the same, 4 and 4. What I do there is I add my exponents. So if I had 4 to the 4th times 4 to the 3rd, my base is the same. Okay, these 4s here are the same. So what you do is it becomes 4 to the, now you add your exponents. That's how you would do that math, is when I have the same base, I write 4, keep the 4 the same, and add my exponents together. So that becomes 4 to the 7th. All right. Now, I want to show you that on your calculator, okay, and probably for the sake of time tonight, I'll just show you that on this calculator, you can multiplying exponents. If you go to YouTube and just type in multiplying exponents, it'll show you the button to press. So you can take 4 to the 7th, okay, and do it real fast. You don't have to do it by hand. 4 times 4, get an answer, take that times 4 and do that 7 times. There's a button to press 4 to the 7th. All right. Having said that, that means if I go back to this screen here, okay, I would have to do the math. If you'll notice, I've got different bases, okay? And so I would have to do 4 times 4 is 16 times 4 is get an answer, and take that answer times 9. 3 squared is 9, okay? That's how I would do that. I'm just kind of 16 times 4 again. I'll just do it real fast here. 4 and a 2 is 64. This becomes 64 times 9. Okay, so you guys wrote that in your notes, so these equations here, okay? And then I would get an answer from there, okay? Likewise, this 4 to the 3rd, okay, would be 64 divided by 9, okay? So in that case, we just do the math first and then multiply the answers to get an answer, okay? So when you have different bases, you got to do the math first. But when you have the same base, like we just showed you here, you keep the base the same and add the exponents and put that as my new exponent, 7 in this case. Okay, so you can do that when you have the same bases. All right, having said that, now what do we do when we subtract? Okay, so I want you to take a moment and just copy what you see on this slide here. Just go ahead and copy that down. All right, so as the rule in red here says to divide numbers with the same base, and that's the key idea here. Again, I want to emphasize this. If you have the same base, you get to do something slightly different. You subtract the exponents, okay? So I have 5 to the 7th, which would be a monster number, by the way. divided by 5 to the third. What I can do is, because I have the same base, again, this is the base, it's the same, okay? Just want to really emphasize this visually, that that's the base and it's the same. Keep the base and subtract your exponents, okay? 7 minus 3 is 4, so that's 5 to the fourth. See how that really simplified things down for you? Okay, so that's what you do if you have the same base, is you keep the base and subtract your exponents. Okay, moving on. All right, kind of a new concept here I want you to copy down is the mean, the median, and the mode, okay? The mean, the median, and the mode. What are they? And the range. There's actually 4 ideas here. And so let's copy down the first one. If you could all in your notes, put down the word mean and put down that mean means the average. That's what that means, is the average. They ask you to find the mean of a group of numbers. They're asking you to find the average. Okay, so you've got mean equals average. Okay, and there are 2 steps. Okay, so in a sense, you got to find it. Step 1. Okay, so if I'm going to write this above this here, just to make this really clear what this is, these are the steps. There's 2 of them, 2 steps. Okay. When they ask you to find the mean or the average of a group of numbers, you probably heard this before somewhere in math. Okay. Step 1 is to add up all the numbers. And then step 2 is to divide by the amount of numbers there are. That is step 2. So copy that down. Step 2, divide by the amount of numbers. So in my example here, I've got 3 numbers. I've got 2, 4, and 6. Okay, I have these 3 numbers. And if they ask you to find the mean, okay, that means the average. Step 1, add them all up. So 2 and 4 is 6, plus 6 is 12. It gives me a total of 12. How many numbers are there total? There's 1, 2, 3. So I divide by 12. And so the average is 4. You'll notice that 4 is not even listed in the list of numbers. So the average is not the mean, or average is not one of the numbers necessarily. It's the one that is the average of all of them. Okay. That's how you find the average, the mean. All right, let's move on to the next concept. Is the medium. I think it's the medium with an M here. Sorry about the misspelling there. The medium. I'm going to have to double check on that. I'm having a brain cloud here on the spelling. Median. Seems like it's median. It's probably the N, median. All right. All right, so this number median, okay, it means the middle number, just so you know, okay? You see median, the median, they're telling you what's the number in the middle. So that's kind of a simple concept. But there's a little trick to finding the middle number when you get a group of numbers. So median equals middle. And there's kind of like 2 steps, if you could copy these in your note. Step 1 is to place the numbers in order from left to right, smallest to greatest. Okay, that's the first step. When they ask you to find the median, okay, not the mean, but the median, the middle number, the first step would be to put them in order from smallest to greatest. Then you choose the middle number. That's the second step if you want to copy that down. Choose middle number. Okay. So in my list of numbers I have on the screen here, I've got 3, 2, 7, 8, and 6. Okay. If they ask for the median, the middle number, I would put them in order first. 2, then 3, and then 6 goes next, and then 7, and then 8. You see how I took all these numbers and put them in order, smallest to greatest. Okay. Then what I do is I would go, okay, which number is in the middle? Well, in this particular case, the middle number is this 6 right here. It's the one in the middle. All right. That's the median. When they're asking for the median, they want that middle number. However, one little twist that will come up occasionally if you have, what do you do? My pink note over here says, With even amounts of numbers, choose the middle two and average those two numbers. I have an example here. If I had 1, 2, 3, and 4, and the average of 2 and 3 is 2.5, okay? So if I had 4 numbers, you see how that's an even amount of numbers? There's no number in the middle here of this pink box here, of these 4 numbers. There's no middle number. You get a middle number when you have an odd amount. But so what you do is you add the 2 numbers up and divide it by 2, because you have 2 numbers. You find the average of the middle 2 numbers. Okay, that's what this is saying. So if you wanted to write that down, if even amount, average of two middle, find the average of the middle 2. That's the concept for finding the median. If you have an even amount, you've got to pick the 2 numbers. And by the way, you would still do the same steps. Place them all in order from smallest to greatest. Choose the 2 in the middle, add them together and divide them by 2, because that's how many you're averaging. And there's your answer. Okay. So that is how you find the median. So you have the mean, the median, and the mode. Please write this word down. It sounds like a science class that I taught for the college, where we were talking about all these concepts. The mode means, please copy, most often. The number that happens the most often, okay? So in my example, if you want to go ahead and copy, because like many of you, I'm a visual learner, so I'll get it better. If you can give me an example and I can see it, how it was done, I'll grasp it better. Most of my learners are like me, they're visual learners. I can read a set of directions 10 times sometimes, but if you just show it to me, like just show me the example, it's like, oh, why didn't you just say that? Okay, it just makes it simpler. All right, so mode means the most often. So that means the number that happens the most often. Let's look at this set of numbers they'll start talking about in math, this group of numbers here. I have a 7, an 8, a 9, an 8, 11, and a 15. The number that occurs the most often, it's the only number that happens twice here, is 8. 8 is the mode of this group, okay? It's the most often, it's the one that occurs the most, okay? It's that simple, really. And you don't have to get them in order, in case you're wondering, because you're just looking for the number that's the most often. So the order would not affect that, okay? And there's a little orange note down here that I put that says you could have 2 or more, and you could also have none. Here's what I mean by this. If I had the numbers 1, 2, 3, 2, 3, and 4, okay? You'll notice in that example, on what I have here is I have 2 2s and I have 2 3s. So is it possible to have 2 modes? Yeah. So 2 and 3 are the mode. They're both the mode. They're both the most often. And likewise, in the example 1, 2, 3, 4, and 5, if they ask you, what's the mode of this group of 5 numbers, you would say, there's none. There's no, okay, there's no mode. Okay, so it is possible just to know that. Likewise, you could have 3 different modes. You could have 15 numbers and 3 of them appear more than once, okay? All right, so that's mean, median, and mode, and that brings us to this concept of range as we're closing down to the end here. Please copy this term, range, okay, a range of numbers. And I'd like you to take a moment and just copy down the definition of what range is. It's take the largest value and subtract it from the smallest value. That's the rule to find it, okay? To find it, that's what I'm going to do. I'm going to take the largest number, subtract the smallest number from it, I should say. The wording of that, and subtract the smallest, I should take this word from out of the sentence, it'll sound better. Take the largest number value and subtract the smallest number. Okay, that sounds better. All right, so the range basically means what is the difference between the largest and the smallest number? That's what range means, okay? So in this example, I've got 5, 7, 9, and 12. Okay. If they ask you for the range here, they want to know, take my biggest number and subtract my smallest number from it. And that's the range. And what it really means is the whole range from all these numbers is 7. There's a range of, the difference is 7 between the biggest and the smallest number. Okay. That's the range. Okay. So range is take the biggest, subtract the smallest from it. That gives you the range. Okay. We've talked about mean, average, medium, middle, mode, most often, and range, the difference, okay, how far they are apart, okay? In this example that I have on the screen here, folks, if you look at this, I've got finding the mean, median, and mode, okay? So if they give you these numbers right here, 3, 6, 8, 8, and 10, okay? And they ask you, find the mean, okay? That means the average. I would add them all up, 9 plus 16 plus 8, and get a total, and divide it by how many? 1, 2, 3, 4, 5, and divide my answer by 5 to get the mean. Okay. If they ask me for the median, that sounds right. It's got to be median. Okay. I would place them in order from smallest to biggest. In this case, they're already kind of that way for me. And because there's a 1, 2, 3, 4, 5, there's an odd amount, I would circle my middle number, and that's my median number. Okay. My mode is the most often. You can probably look right away and say, oh, 8 is my mode. It just happens to be that the median and mode are both 8. It will not always happen like this. My range is 10, the biggest number, minus 3, the smallest number, is 7. They're 7 apart in this case, okay? All right, so that's how you would find the mean, the median, the mode, and the range. By the way, in a science class, you do that same idea. Okay, I did pretty good. We started at about 7:10 and I ended at 8:10. If you have any questions for me, be sure and send me some kind of an email, and I'll be happy to answer your questions.